Hey everyone, Mr. H here, going to do some 5.2. This is page 6 of the chapter 5 notes. It's on normal distribution finding probabilities. This is where you apply what you did in 5.1. So these are the word problems associated with this concept. You can think of them as two steps. First, you're going to convert a raw score to a z-score using that formula that we saw in 5.1. And then we're going to use either technology, that means StatCrunch, or the table to find the area, just like we did in the last video. So let's get right to it. Here's number one. You have a mean. You're always going to be given a mean and a standard deviation, and then asked to find some kind of probability. So this is to find the probability that x is larger than 120. So first step, z-score. And the formula, as a reminder, is this. So the x that you plug in is always from the question, right, what you're trying to find. The mean is the population mean that is given, and then the standard deviation. So this is, do the subtraction first, 1.33 approximately, okay? 2 decimal places is sufficient, especially if you're going to use the table. That's all you can do is 2 decimal places for the z-score. Okay, now let's convert that to an area. Basically, you're trying to find greater than, so that would be an area to the right of the z-score 1.33. So if it's area to the right and you're going to use the table, look up 1.33 and then subtract it from 1. So let's do that. So I'm going to 1.33, and that's 0.9082. And so I'm going to do 1 minus that. 1 minus 0.9082 is approximately 0.0918, and that would be your answer. Okay, if you were to use StatCrunch, remember how that works. You go stat, calculators, normal. Make sure you have the right inequality. So this is greater than, and then I would enter in my z-score of 1.33 and compute. And there's your 0.0918, just like we got with the table. Now here you have the option of even doing a little more accurate, because the answer, the z-score was actually a bunch of 3s. And so you'll see that differs a little bit, 0.0912. Both should be marked correct in MyLab. Okay, so use StatCrunch or the table, doesn't matter. Let's get back to the handout and try another one. In the next problem, we have a survey conducted to measure the heights of men in the US. And so what I'm searching here for is a mean. There's the mu, and a standard deviation. There's your sigma. And then my first question is less than 66. So key is getting the inequality right and using this as your x value. Okay, so the z-score is going to be 66 minus the given mean above, 69.6, divided by that standard deviation. And then you can just round that to 2 decimal places. So just in your calculator, make sure to do the subtraction first. It's negative 3.6 and then divide by 3. So this is exactly negative 1.2. Okay. And then since this is less than, you can just look it up directly in your table, or you can do your StatCrunch. So I'm probably just, since I have StatCrunch up, I'll just do it less than negative 1.2. Okay, and we're getting 0.1151. If you're using StatCrunch, you'll never have to do like subtract from 1 or anything like that. It'll just give it to you directly, 0.1151. Okay. Table should give you the same thing if you want to verify that. Now, a cool thing is, while we have StatCrunch up here, there's the super duper shortcut, because notice here, we've been just keeping mean 0, standard deviation 1, You can actually change those to fit the word problem you're working on. And it will do it all at once. So if you don't necessarily need to find the z-score, some problems you will have to find the z, so I got to do that first step. If you don't, you can do it this way. So I can enter in the mean in the problem, 69.6, the standard deviation 3. Now I'm going to be putting the actual x value here, 66, okay? So that setup will give you the answer directly. There it is, the 0.1151, okay? Let's try that with the next problem, part B, that says the height is between 66 and 72. So instead of finding z-scores for each of those values and then, fiddling around with tables, we can just use this program. I'm gonna go between. I got my mean, my standard deviation are right, and then I'm gonna put between, so it's 66 on the lower end and 72 on the higher end, and I get my answer 0.6731. If you want to practice using the formulas and then doing the between, feel free, or you can just do it the super duper shortcut way, right? Still know how to find a z-score, because that may be a question, right? So if you don't know how to find a z-score, you might miss a problem on the midterm. Okay, how about that last one, which is more than 72 inches? So I got to go back to standard. More than is greater than, and 72, compute, 0.2119, okay? And then there we have it. So not too bad when you have StatCrunch and you know how to use it. Okay, cool. So I jotted those answers down on the handout. Didn't really do any work because we use StatCrunch. Here's another one. If you want to try these on your own, go for it. Just hit pause and try them out. Otherwise, I'll just run through them right now. So what do we have? Got some stuff, numbers that we don't need. This is all descriptive, so don't need that. There it is, mean of 24.2, standard deviation 4.3, first question less than 17. All right, so let's try that one with that StatCrunch method. So here's my StatCrunch calculator up still. So the mean is 24.2. Standard deviation is 4.3. And less than 17. And there we have it, 0.0470. 0.0470, okay? How about between 20 and 29? All right, between 20 and 29, 0.7035. All right, so not too bad there. More than 32 would look like back to standard and a greater than. And those are pretty much your three options, right? Between, less than, or greater than. So more than 32, 0348. All right. Let's head back to the question. So now some additional questions that you might be asked. Are any of the above probabilities unusual? So our standard rule is if the probability is less than 5%, we're going to call that unusual. All right. Another thing that we'll use is if the z-score is more than 2 or less than 2. So those are two rules that we're using right now. So if any of these are less than 5, go ahead and call it unusual. So we're going to go with A and C on that. And then if 200 high school students are randomly selected, how many of them would you expect to get a score of less than 20? Okay, well, we didn't find less than 20. Let's do the less than 20 the old-fashioned way on this one, just to practice finding that z-score again. So if I needed a z-score, I would do 20, because I want less than 20. And then the mean was, going back up, 24.2 divided by 4.3. All right, and then use your calculator to get that. And that's about negative 0.98. Right, and then less than that, you're either going to use your table or StatCrunch. So let's try table, since we haven't done table in a while. So there's a lot of different ways going on here. Kind of got to pick your favorite and go with it, or know them all, I guess you could do. Right? So negative 0.98, we're going to go to this table here, negative 0.9, and then over to 8, which is that second column, 0.1635. So the area, the percentage is 0.1635, right? If I'm not confident with that, I can double check it with my StatCrunch, less than 20, okay? 0.1643 is what I get for that. You know why that's a little different? This one's more accurate. The reason is because when we did it by hand, we had to round that z-score and then use that value. You're going to be a little bit different when you do that. Either way, again, my lab should be happy with your answer. Okay. Okay, well, we're not quite done with this problem because it asked one additional thing here. So jumping back to the handout. It said, if 200 high school students are randomly selected, how many of them would you expect to get a score of less than 20? So we would expect about 16% of them to get less than 20. But to find the number of students, I would have to multiply that percentage times the 200. And then round to the nearest whole person. So this is 32.7, which then I would round to the nearest whole number. I would expect 33 students total, right, to have that GPA. Okay, next up is going to be the next section. So that's the end of page 7. I'm going to stop there. Hope everything's going okay. Send questions my way if you have any. All right, talk to you later. Thanks.